Hello everyone and welcome back to the Fluctus Channel. Shiplifting technology is not a new concept. But in China, it has become central to the country's inland waterway development. Traditionally, when ships encountered large differences in river elevation, locks were used to gradually raise or lower vessels. However, as China built massive dams for hydroelectric power, such as the Three Gorges and Gubitan, water level differences became too great for traditional locks to handle efficiently. To solve this challenge, engineers began turning to shiplifts. These are essentially giant elevators for boats, designed to raise or lower vessels along steep elevation changes in a fraction of the time it would take to pass through a lock system. China has emerged as a leader in this technology, constructing some of the world's most advanced and ambitious lifts to keep its rivers navigable despite massive dam construction. China's geography makes river transport essential. The Yangtze River Basin, for instance, carries nearly half of the nation's total waterborne freight. Inland provinces depend heavily on these waterways to move goods such as coal, grain, raw materials, and manufactured products to coastal cities and export hubs. As the nation raced to build hydroelectric dams to meet growing energy demands, river traffic risked being disrupted. Dams created enormous elevation differences, in some cases exceeding 100 meters. Without a way to bypass these walls of concrete, commercial and passenger shipping would be severely restricted. This is why shiplifts became so vital. They preserve river transport routes, maintain the economic lifelines that connect China's inland provinces with its coastal ports, and demonstrate the country's ability to combine power generation with large-scale logistics solutions. In this sense, shiplifts are not just pieces of engineering, but symbols of balance between infrastructure, energy, and trade. Among China's impressive projects, the Gubitan shiplift stands out as one of the most ambitious. Located on the Wu River, a tributary of the mighty Yangtze, the Gubitan Dam rises nearly 200 meters high. For vessels to bypass this barrier, engineers designed one of the tallest vertical shiplifts in the world. The Gubitan shiplift functions like a colossal elevator, raising ships up to 100 meters between the upstream and downstream levels of the dam reservoir. Its structure is striking: massive steel frameworks, concrete towers, and a chamber large enough to cradle ships weighing up to 1,500 tons. It is often described as crazy engineering because of the sheer scale and precision involved. Lifting something as delicate as a floating vessel, while accounting for water displacement, buoyancy, and shifting weights, is a challenge that requires state-of-the-art hydraulic systems, motors, and balancing mechanisms. The Gubitan shiplift represents a staggering investment. Reports indicate that the entire project cost several billion yuan, reflecting both its engineering complexity and its importance to national logistics. Some of the statistics are equally impressive. The vertical lift can accommodate ships up to 85 meters in length and about 12 meters wide, carrying weights of over 1,000 tons. The lifting chamber itself is essentially a water-filled cradle, weighing thousands of tons when loaded. Despite this, the shiplift can complete a full vertical movement in around 20 to 30 minutes, drastically cutting the time needed compared to traditional lock navigation. In terms of efficiency, the Gubitan shiplift is designed to handle dozens of vessels per day, ensuring smooth and continuous traffic along the Wu River. This capacity makes it not just an engineering marvel, but also a practical solution to maintaining economic connectivity. For a ship captain approaching the Gubitan Dam, the process is both surreal and seamless. Vessels sail into the massive steel chamber, which is already filled with water. Once the ship is positioned and secured, giant gates close behind it, sealing the chamber off from the river. From there, enormous hydraulic pistons and counterweights spring into action. The entire chamber, complete with the ship and its surrounding water, begins to rise vertically. Engineers design the system with incredible precision, ensuring that the lift remains balanced despite the thousands of tons of shifting weight. Once it reaches the upper level, gates open again, and the ship sails seamlessly into the higher reservoir, ready to continue its journey upstream. The reverse process works the same way for vessels heading downstream. In either direction, what might have once taken hours through a complex lock system can now be achieved in a matter of minutes, revolutionizing river navigation in the region. The U.S. Navy employs some unique and advanced engineering to accomplish its missions while sailing around the world. When the aircraft on a carrier are not in use, most of them are secured in the hangar bay. This area has a total length of more than 2/3 the total size of the entire vessel, and is capable of holding at least 60 aircraft and heavy equipment like spare engines and fuel tanks. Basically, the hangar bay can be considered as a giant garage for fighter jets and helicopters. With its 3 decks high, the bay is surrounded by several compartments as well as having multiple safety measures, such as fire suppression systems. To move the aircraft to the flight deck, the crew uses spotting dollies, which are 3-wheeled vehicles similar to tractors with hydraulic arms at the front. They help to maneuver the jets through the tight spaces of the hangar bay with precision. The hangar bay also includes the workshops and maintenance areas where technicians can perform essential repairs, checks, and refits on the aircraft. Critical components of the aircraft, like the pressurization systems and oxygen to the ejection seat, are under constant inspection and upkeep. This forms part of the preventative maintenance programs that are regularly performed. However, the training of the crew not only involves prevention, but corrective maintenance. As part of the maintenance department inside an aircraft carrier, the tire shop is in charge of inspecting, replacing, and cleaning all aviation tires and rims. The trained crew members inspect the treads of the tire to see if the part needs to be placed into a beyond capable maintenance status, meaning there is no chance of repairing the tire. If possible, the tire might get into a deconstruction and reconstruction step for later use. Considering that the hangar bay is at least 3 decks high, it has several elevators capable of moving the aircraft to the flight deck when needed. These powerful hydraulic elevators can generate enough force to lift 2 fighter jets, or a total of 74,000 pounds. Readiness to any situation is key for the crew members of the carriers, which is why constant training exercises are carried out throughout the year. Inert training bomb movement is done from the magazine to the flight deck during flight operations. Munitions, like the 500-pound Mk-82 bombs, are transported using specialized load carts that move around the carrier through the use of their inner elevators, leading to the upper deck. Then the munition is transferred into lift trucks for loading the aircraft. Being a training exercise, the bombs contain no explosive material, but an inert one to keep with the original weight of service ammunition. All the ammunition and weapon systems of the aircraft carrier are stored in the weapons magazine. Here, the specialized rooms have blast-resistant airlocks and several safety devices, including a system to flood the compartment with seawater in an emergency. Also, redundant systems and backup plans are implemented to ensure continuous operation in case of any emergency. Considering these safety procedures, not only the weaponry of the vessel itself is stored here, but also the weapon systems of the aircraft that are stationed on the ship.
I work in every magazine. It's G3.
During naval operations, the aircraft carrier magazine is used to manufacture ordnance for the ship. This vital process works like an assembly line in a factory, where the highly trained crew members build the ammunition to be ready for the mission. Knowing that the urgency of the missions needs it, weapons have to be built on a tight schedule as a #1 priority. Thanks to this, each piece of ordnance is built by a team of 10 to 15 people to obtain the piece with the required quality and time. Before the 20th century, the refueling process of a ship relied on coaling stations set in key locations for the fleets to get the required fuel during their travels. However, this demanded multiple defended locations during times of warfare, which resulted in an infrastructure that was constantly in danger in case of any disruption. The development of a new system in which a ship could be refueled by another ship, called underway replenishment, started in the early 20th century, achieving operational use during World War I and used extensively during World War II. After this period, the alongside connected replenishment method was created to transfer liquid fuel as well as ammunition and goods between ships. Nowadays, newer technologies like the standard tensioned replenishment alongside method, or the involvement of airships, such as helicopters to transfer cargo, in a method called vertical replenishment. The refueling process requires using a span wire fueling rig that extends the hose from the delivering ship to the receiving ship at a safe distance. To connect this system, a pneumatic line thrower launches the messenger line that pulls the transfer lines to the receiving ship. In the case of bigger ships like aircraft carriers, multiple rigs are settled to increase the load transfer rate. It is important for the crew to maintain control over the safe distance between the ships, as two ships getting closer might create a suction event and an eventual crash. The arrival of the 21st century led to the development of a new design with a heavier capacity. This meant that the system could transfer 25 loads of 12,000 pounds per hour. In the end, both China's shiplifts and the U.S. Navy's carriers highlight humanity's ability to tackle enormous challenges with ingenuity and scale. Whether it's raising 1,000-ton vessels over towering dams or moving aircraft and munitions with precision at sea, these engineering achievements show how critical innovation is to keeping global trade and security moving. They're not just technical marvels, but lifelines for economies and defense, proving that when nations invest in infrastructure and logistics, they also secure their future. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.